All right, so we're going to continue looking at vector equations of lines. In the previous video, we looked at the vector equation of a line when you're given a point and a direction. This time we're looking at the situation where you get given 2 points. So it can be quite a challenging idea, but this is basically it. This is how you define the line in space when you get given 2 points. You'd say that the vector r of t is equal to some vector a plus t multiplied vector b minus vector a, where t is an element of real numbers. Can be challenging, but let's step it through step by step. So the first thing we're going to say is, right, this is the 2 points. Well, where are those 2 points? Let's just make them up. Let's say that the point A is here. Remember, a vector is just a line with a magnitude or a size and a direction. So we're going to create a vector between there. We're going to call that vector A. So OA, the vector OA is the same as vector A, same. So that's some point in space A. Okay, the next thing we're going to do is we're going to create some other point. Our other point is going to be B. I'm going to call that B here. Okay, by the same logic, OB will be equal to vector B. And now basically our question is, what is the line? What is the vector equation of the line that goes through AB? So we can even just make the vector AB just to get a feel for what we're looking at. We've got this vector that goes between A and B. We'll call that vector AB. But we're interested in the line that goes through this point, A and B, in both directions. And so let's jump into it. And this is the answer, right? This is it. And it can be hard to sort of see why it's the case, but I'll explain in a moment. But basically, we get this vector r of t, which is equal to vector A plus t multiplied by vector B minus vector A. Okay, you're probably like, what on earth is going on? But let me just show you what this point P traces out. See what you notice about P as it travels along. You notice it's on the line. That point P is on the line between A and B. So how cool is that? Tracks it out, right? So you're probably wondering, well, why does this equation necessarily give us that line? Well, or the points that are on that line. Well, let's have a think. Let's think of some examples. Let's give some example vectors. You noticed there that I was changing the value of t. Remember, t is this parameter that we can change, so that when we change it, we get all the points p on that line, right? So let's pick t to be some nice, understandable values. Let's pick t to be 1. Okay, when t is 1, we get the pink line on top of this vector b, and that should make sense. Because if we substitute t being 1, we get vector a plus 1 group of vector b minus vector a. Well, we're going to have vector a minus vector a in here when we expand that 1 in. So we're just left with vector b. So when t is 1, we get vector b. Okay, so hopefully you can sort of see what, at least in that case, why that pink line traces out the line that we're interested in. Let's do another example vector. Let's pick another nice value for t. Let's pick t being 0 now. Let's see where our r vector is, that pink line. It sits on top of this one here. It sits on top of vector a, doesn't it? Well, that should make sense. If we substitute 0 into here, it's vector a plus 0 groups of vector b minus vector a. That's just 0, so you're just left with vector a. Okay. You can pick other values of t, and you obviously get a path that's traced out by this pink vector. And the way you need to understand that is through vector addition, okay? Vector addition and subtraction. So I encourage you to get out a pen and paper and maybe pick values of t and trace out the different points, but you'll get that your vector is always going through these points. And coolly enough, we can put the line that it traces out. So it traces out this line, right? So you notice that those values p are always on that line there. Now, what's really cool about this is I can change the values of a, right? A doesn't have to be there. If I change a to be there, and then maybe b to be, oh no, one sec. I'm not sure what happened there, but my point B wasn't cooperating. And here we go, B is cooperating now. So we can see if we change these points A and B, oh, it's not going to work again. Hopefully you get the idea. I've got to select A. There we go. Now I've got to select B, which is that point there. There we go. We can get it moving how we want it to. Anyway, the conclusion is that that vector R hat, or that vector R, traces out the points between traces out the line that would connect the points A and B. So a bit of a challenging idea. Hopefully you found that useful. That is how we define a vector equation when you're given 2 points. Let me know how you went with that idea, and good luck with all your studies.